Hello class, in this video I'll be showing you an application of the graph of a function. Let's begin. A golf ball is hit with an initial velocity of 130 feet per second. The height of the golf ball is given by the function h of x, where x is the horizontal distance that the golf ball has traveled. Now before I go ahead and answer any of these questions, I just want to make sure that the graph of this function does indeed model the height of the golf ball after it's been hit. So I'm going to go into Desmus and do that now. So the equation has already been entered, and notice that right now it appears that the equation or the graph of this equation is a straight line. Now golf balls don't travel in straight lines, they go up and then they come back down after they are hit. So what I'm going to do is I'm going to change the viewing window to determine if this graph does indeed go up and then come back down. So I'm going to go ahead and hit this wrench over here in the top right hand corner, and notice that I can change the values of the x and the y axis. So starting with the x axis, I'm just going to make those numbers bigger until I see if the function does ever decrease. Oh, and there we go. So the function does decrease, and it looks like the ball doesn't travel further than 600 feet. Now I'm going to change the values of the y-axis until I can see the highest point of the graph. And notice after getting to 100, I can almost see the highest point of the graph. So I'm just going to zoom out just a little. And now we can see the highest point of the graph, and this does indeed model the height of a golf ball after it's been hit. So let's go ahead and answer the first question. Determine the height of the golf ball after it has traveled 40 feet. Okay, so this 40 feet is a horizontal distance. And the horizontal distance is represented by the letter x. So here the problem is asking to evaluate the function when x is 40. So I'm going to go ahead and substitute 40 in for x. And I'm going to use Desmus to solve this. So we're looking for h of 40. So it's approximately 36.97. So the height of the ball is approximately 36.97 feet. Okay, question B. How far was the golf ball hit? Okay, so I'm going to draw the graph for the height of the golf ball. And this is the start, and this is the finish. And notice in both instances, the height of the golf ball was equal to 0. Okay, so what I'm going to do is I'm going to set this function equal to 0. And I'm going to use Desmus to solve for x. So here we go. Okay, so here we want the height of the golf ball to be 0. So notice there's now a blue horizontal line through the x-axis. And what you can do is you can click on the two intercepts, and Desmus will give them to you right away. So it looks like the ball traveled approximately 528.13 feet. Okay, question C. When the height of the ball is 75 feet, how far did the ball travel? Okay, so just like the previous problem, I'm going to draw the picture. So here's the start, and here is the finish. And the ball has a height of 75 feet in approximately 2 places. So what I'm going to do is I need to find both of those locations. So I'm going to set this function equal to 75 and then use Desmus to solve for x. Okay, so this time we want a height of 75 feet. So it looks like the ball was approximately 90.51 feet and approximately 437.61 feet. Okay, now for the last question. Create a table where the change in x is equal to 25. To the nearest 25 feet, how far does the ball travel before it reaches its maximum height? Okay, so just as a reminder, the triangle x represents a change in x. So what I'm going to do is I'm going to make a table in Desmus where x starts at 0 and then I go every 25 feet. So 25 feet, 50 feet, 75 feet, etc. So in Desmus, I'm going to come over here, I'm going to type in the word table. Now notice that the table provides an x sub 1. You need to get rid of that 1, so we're going to hit the over arrow here. So now that's just x. And where the y sub 1 is located, you're going to hit h of x. Now if I type in 0, notice the output value is 0. And I can keep adding more rows. And notice that on the graph, they'll place coordinates where those entries are located. All right, so I'm going to keep going here. So we're going to go 125, 150, so we're still not at its maximum height yet. 175, still not there. 200, 225, getting closer. 250, and then 275, and one more for good luck here, 300. So it looks like that's somewhere around 275 feet, the ball will reach its maximum height. So we're not looking for the exact value of x, we just want to the nearest 25 feet. So at 275, we have the largest output value, so that is going to be our answer, 275 feet. And we are done.